Hello again, YouTube. Welcome back to my channel. My name is McPato and this is McPato PC. And I'm taking a break from some of the other videos I've been working on. As well, I've been getting a lot of overtime at work and it's been snowing like crazy where I live. So I've been pretty busy this month. Just wanted to take a few minutes, make you a video on how to overclock, specifically Vega. But if you guys have an RX 580, 590, 480, 570, 470, whatever AMD graphics card, and even non-AMD, although specifically the part with AMD Wattman will not apply to you. But I get asked very often how to overclock. I get asked what programs I use and what settings I use and how to do it. So we're going to make a quick, probably 10 or so minute video on the basics, the fundamentals, and we'll go through the programs. I'm going to do OverdrivNtool as well as Wattman, and if there's time I'll do a quick overview of MSI Afterburner, but it's not my favorite for undervolting. I'll be honest, I've never undervolted using MSI Afterburner. I find the other two programs are much easier than what it appears to be in MSI Afterburner. So anyway, for anyone who doesn't know what is overclocking, or you've heard the term and you're not exactly sure, when it comes to computer hardware, specifically video cards, often you can increase the performance by changing some of the settings. There are two basic parts to a video card that you can overclock: the memory speed and the actual GPU, or the graphical processing unit, and both will have an impact depending on the video card you're overclocking. It may have more of an impact. For example, the HBM speed on Vega has a pretty significant effect on your performance, more than if your memory can go up 100 megahertz. It'll probably do more for you than if you get 30-40 megahertz on your GPU. So in a nutshell, those are two of the things you can overclock. And another thing you can do very, very easily is increase your board power limit. So the amount of electricity going into your card can be increased. And there's some danger if you go too high, but both OverdrivNtool and Wattman, AMD Wattman, which we will be covering, there's not any risk of damaging your card if you stick with the default. You can go into BIOS modification with power play tables, or you can download different BIOS, basic input output system, which tells your card what it is and how it can perform. You can actually modify those and get more performance than is intended, even from AMD. For an AMD card, you can blow the thing up if you want to by modifying these settings. But again, if you stick with what I'm showing you in this tutorial, there's not any risk of blowing up your Vega or your Polaris or whatever card. So that's the first disclaimer. So increasing that board power limit, you can go up to 50% increase using Wattman and OverdrivNtool. That 50% increase will do wonders for getting a stable clock speed. It's just going to really help you with everything, and it's going to help you get those higher clocks as well. But there's always a trade-off. As your clock speeds go up, and that's the speed at which the thing is working, it's usually measured in megahertz or gigahertz. As that goes up and voltage increases, you're going to get more heat, and heat will actually make your card work slower. So it's kind of counterintuitive. You can increase the speed, like for example in your car, if you can redline your engine and you're going to be going the fastest it can go, but you'll blow up your motor. So maybe that's a bad example because you probably won't blow up your video card as long as you stay in these safe guidelines, but it's going to overheat, and video cards and processors and electronics are often set up to, as they get hot, so let's say it gets to 60 degrees, it lowers the maximum performance that it will give you because of the temperature. So it's trying to protect itself from getting too hot. So you increase the voltage, it runs a little faster for a little while, but when the temperature catches up, it'll actually start to bring down the speed. So how can you counter that? Well, you can counter that with improved cooling. So you can get if you have a reference card, you can get a aftermarket cooler like the Morpheus 2, or you can put on a custom water block, or you can get an AIO from, for example, AlphaCool. So these are some options, and keeping it cool will give you the option to increase your performance and not worry about throttling, is what it's called. So there's that. You can also do something called undervolt. So electronics, it's called the silicon lottery. So basically the chips are made and there's a spec that it will work at. And instead of going in and checking every individual card, AMD will just, and NVIDIA does the same thing, but they'll make it passes the test at these settings, and then it's called this. So out the door it goes, Vega 64, and it runs at this voltage. You can actually go in using these programs and lower the amount of voltage going to the GPU at any given, it's called a P state. So at the highest P state, P7 on a Vega card, you can tell it, you know what, I don't want you to use 1200 millivolts, which is the default. I would like you to try running at 1150 millivolts. So that 50 millivolts reduction will give you cooler temperatures. So if, for example, you're able to get 1600 megahertz at 1200 millivolts, just by lowering the millivolts to 1150, you might be able to go to 1230, 1240 megahertz just because it's not getting as hot and it can run. It's trying to turbo all the time at the fastest it can, provided it's operating within certain temperature limits. So that's another way. Now, if you combine the two, you can start to get into some pretty good performance, overclocking and undervolting. So I'm going to show you guys how to access those settings and how to test it in real time to get the best performance for your card. So we're going to jump right in with the programs that I would use, that I do use, and I'll show you guys how I make it work together. All right, let's jump right in. All right, so the first thing I'm going to do is show you guys the programs that I use. Again, I'm not sure if I mentioned it, but all of these will be linked in the description below this video. So if you guys want to download them, that'll make it nice and easy for you. The first thing we're going to open up is GPU-Z or GPU-Z, depending where you live. And this is a good program for a lot of reasons. The first reason is it gives you a lot of information on your current settings, your video card, your driver, all of that stuff. So down here you can see the default clock speed, the memory speed you're running at. You can see your driver version, driver date, the type of memory you have, and the manufacturer, how much memory, the speed, all that stuff. Another neat thing you can do with GPU-Z is you can go right here and you can actually save your BIOS. Now this is useful when you get into some more advanced stuff. And I will show you guys in OverdrivNtool, you can actually edit the power play tables. And in order to do that, you need a BIOS file. So this is a good way to get that file and make those changes. I'm not going to cover power play tables in this video, but if that's something you are comfortable doing, then this is a good way to do it. You can also download a lot of different BIOS versions from Tech Power Up. In their download section, you'll find quite a variety. So anyway, moving along. Another thing that GPU-Z is good for is your sensors. And I've configured this to show the sensors that I want to see. And the way to do that is to go to your sensors here, and you can check off what you want to see. As well, you can check off your your refresh rate cycle, and you can tell it what you want to see. So if you want to see your highest clock speed, your average, your lowest, or your current, you can set that here as your default. You can also set it right here, so I can pick any of these settings or readings, and I'll be able to see it as well. But if you always want to see the maximum, you can set it as your default. It's by default set up for current reading. So in a nutshell, that is what GPU-Z is. It will log to a file if you want. I've got mine right here on a desktop, and it'll show you important information when you're trying to overclock. For example, your temperatures and your clock speeds. So we're just going to put that off to the side here. You can actually also take screenshots using this. So if you attain like a really fast speed and you want to take a picture of it to remember what your temperatures were or your settings, what have you, then that's a way you can do it as well. So moving along, we're going to open up something called Heaven, which is a benchmark tool from Unigine. And this is a good one for a variety of reasons. You can obviously choose your settings here, quality, tessellation, all that. But I have a 1440p screen. I pick a resolution of 1920, and I don't check off the full screen box. If you're using, for example, 1920 by 1080, you could choose the 1600 by 900 option to do what I'm about to show you. But effectively, you can launch it, and there's going to be some audio. I'm going to try to stop the audio, but there you go. That was pretty easy. Sound. So, all right. So we've got our GPU-Z running, and now we have our Heaven benchmark. And the reason I didn't click full screen and I chose a resolution that's less than what I'm running my default at is so that I can see the entire screen. So my whole monitor, so I can still see the GPU-Z application. And what we can see here is that it's running at 1460 megahertz roughly, and the memory's running at 945 megahertz. And our temperatures are here as well. So it's worth mentioning I'm using the default or balanced profile with my AMD Vega 64. I do have a Morpheus 2 cooler installed. It was a reference card before, so I installed an aftermarket air cooler on it, and it makes using my Vega much more enjoyable. You'll note that the temperatures are still kind of high for the clock speeds, and we're going to get into that right away. But as this is working, basically it's going to warm up the GPU, and we're going to get sort of a more stable clock speed. So we're going to open up now AMD Wattman. So to do that, you can click here on Windows 10, and it's this little guy right here. It says Radeon Settings. Right click it and open Radeon Settings. That'll bring up this screen here. We'll click on gaming. Then we'll click on global settings. And finally, global Wattman. All right, so we're gonna let that run in the background. And as you can see, it is using the balanced profile. In order to make any changes at all, we're gonna have to move this over to custom. So now we can see we don't have any power limit applied. Our memory's running. Or actually, I should go through this with you. This here is your GPU. So these are your clock speeds, your voltages, and so on for your actual processor on your video card. This is your fan control. This is where you can set up different performance for your fans at different temperatures. Here's your power limit slider. And down here we have our memory and memory voltage. We are not going to touch the memory voltage at all. It's not worth playing around with. And it's tied into one of these P states anyway. So I don't understand it completely, but I've read it and I've heard it before. So we're not going to mess with the voltage for our memory. Now, if we open up the GPU Z again, we can see that we're hitting pretty high temperatures and our clock speeds are not that high. So what can we do? Well, first thing we're going to do is apply a custom fan curve. So we're going to click on this here, and that's going to change it from automatic to manual. And basically these little dots represent different temperatures, and you can pick how fast you want the fan to work at that temperature. So right now it's set up that at 30 degrees Celsius the fans are turning at 11%. So let's say that that's good, but I want it at 40 to turn at 30%. So I would do this. Then I would hit apply. Okay? You can make multiple changes before you hit apply, but I'm just showing you. And then we're going to say when it hits 45, we want it to run at 46% fan. And when it's at 50 degrees, we want to be at 61%. And then if it actually hits 55 degrees, let's say 80%. I'm just going to hit apply. So I don't know if you can hear the fan, it just ramped up. So we're going to open up our heaven here, and we're going to open up our GPU Z. And we can see that our temperature is going to start to go down. And as the temperature goes down, we're probably going to see the GPU core clock go up. Okay, so that's the first thing. You want to keep your video card nice and cool when overclocking, or as cool as possible. So I could increase the fan even more. As you can see, we're only at 80%, but even so, I brought the temperature down 10 degrees or so. That gives us some headroom, and we're hitting faster clock speeds. Okay, next thing we're going to do is we're going to move the power limit slider all the way over, and we're going to hit apply. What is that going to do? You can see that we're now going about 100 megahertz faster. And that's just from increasing the fan and moving that slider. So our temperatures are now back up because it's getting more voltage. And you can see that under the GPU only power draw, we're at around 275, 280 watts. And that's right over here. And that's up from 218 before we moved that slider. But we're stable at 60 Celsius, and we're putting out, 1550-ish megahertz. So pretty good result already. But let's say that those temperatures are too high. Well, we can now try the undervolting method. So we're going to click on voltage control over here. You can see that it's set up at a default of 1200. And actually, let's click on this here too, to dynamic. And you can actually see your real-time clock speed. So we're going to change this 1200, and you're going to have to play around with this. I know what my numbers are and what it will work at. So for the sake of saving time, I'm just going to punch in 1125 millivolts. And I'm going to change this one here to 1110. And I'm going to leave this one at 1100. Okay. Now before I hit apply, let's take a look again. All right, so we're at 1530 to 50 megahertz. Our temperature is at 60 degrees, and our hotspots at 95, HBM 62, and our power draw 260-ish watts. Okay, now watch when I hit apply. Okay, so our clock speeds are now into the 1610-ish range. Our temperatures are going down. Our power consumption is going down quite a bit. And our HBM's down. So we're getting faster speeds using less electricity and running cooler. Pretty good deal. Now, we've done all that. Maybe we'll apply a little faster fan curve. And again, if you're using a reference cooler, this might not be possible for you based on the fact that it's very loud. But we're just going to do this to demonstrate sort of the maximum benefit of overclocking. So yeah, we're nice and cool. Our clocks are good, stable. Also, you'll notice they're not bouncing around like before. They're staying, well, they bounce around a little, but when they're at 1605, it's not going to 1620, 1605, 1615, 1580. It's kind of sticking to something pretty consistently. So now it's time to start pushing the clock speeds up. Okay, so it's set up to go 1632. You can see that we're not running at 1632, we're around 1610. So there's some difference between the number you punch in and the actual number it will give you. But let's just try for the sake of trying. Let's do 1600, 85 megahertz. Okay, and we're going to go more, apply, and we've done it. So now let's take a look. So now we're up to 1657, 1660-ish. Our temperatures have not gone up very much at all. Our power consumption is up a little bit. And yeah, that's the basics of overclocking your GPU clock in AMD Wattman. You know, and obviously it can go faster, and you're gonna find that as you're gonna hit a wall. So maybe you punch in 1700 megahertz and it crashes. Okay, it's not gonna cause any damage. It's probably going to reset everything because the computer will say that something went wrong. Let's go back to the balanced profile. So what you can actually do in this software is you can save a profile. If you click on that, you can name it. So you can name it Overclock or whatever you want. And if it crashes, you can just load it, go to load profile, pick that one, and you'll be right back where you were before the crash. So as I was saying, let's say you get to 1725 there, it crashes, you reload, you have two choices. You can either try lower speed, so maybe 1715, 1710, or you can increase your voltage. So you might go to 1130 millivolts or 1135 or 1145 to try to get that specific clock speed that you want to get. Okay, so using that system, so either you drop this lower, 1115, 11.5, maybe 1065 millivolts, then you get a crash at 1687 megahertz. Well, now you need to increase the voltage or lower the clocks. Okay, and that's sort of the fundamental of overclocking your GPU core. And as you can see, the program's still running in the back. The temperatures are still good. We're almost 1670 megahertz. I mean, I would call that a successful overclock. We're about 200 megahertz, 240 megahertz faster than we were before we did anything. So certainly you're going to get better performance. It's running cooler and it's using less power. So those are all wins. Now, another thing you can overclock is your memory. So that right down here, you can take this slider and just slide it up. And you'll see that the number here changes. Now, let's say I wanted to try 1055, which is a 110 megahertz increase. I would go over here and hit apply. Now I can see that I'm running at that speed. And again, some people can't get this with Vega. Some people can. Some people can go, I can go up as high as 1160 megahertz and it does not crash. So it literally will come down to what specific card you have in your hands, not the model, or, there's some variance in what it will actually perform. So memory, same thing. Increase it slowly, 25 megahertz at a time. If you get a crash, and don't work on both. So if you're doing memory, don't play around with your GPU at all. Just do the memory. So if you get a crash, you know that you're crashing because your memory is too high. So do one and then do the other. When you get a stable GPU clock, okay, it's time to move on to your memory, or once you get a good memory clock, move on to your GPU. So that'll conclude the AMD Wattman tutorial. And again, don't forget to save your profiles. The other option, if you don't like this one, is called OverdrivNtool, which is right here. It doesn't look quite as pretty, but it's pretty straightforward and down to business right away. And pro tip for anyone who wants to mess around with power play tables, you can actually right click on the little icon of the video card in the corner and go down here to PP Table Editor. It wants you to load up a BIOS. So remember earlier I showed you guys where you can save a BIOS using GPU-Z. You can then open that file up and you can start to mess around with your power play table. I'm not going to do that right now. That can actually cause a lot of problems if you don't know what you're doing. So we're going to leave that alone in this tutorial. And since the latest driver revision, I find I cannot change the target temperature, for example, or the fan speeds in this program. I used to be able to do everything from here. Now only AMD Wattman can control the fan. So that's that. But you can increase or decrease your millivolts and your megahertz for your different P states. P7 is that if it's running like all out, that's your P7. If it's able to kind of calm down a little bit, that's your P6, P5, P4, so on. To the point where if it's just sitting on your desktop and you're not playing a game or doing anything, P0 or P1. So these can be much more efficient than, you know, P5 to 7, let's say. And I would, you know, if you're doing a good overclock, I would increase, you know, P5 and up. So like P5 could be, I don't know, 1550, and this guy could be 1585. Let's apply that. So that way you're going to get sort of better performance throughout the curve. And yeah, so that's basically OverdrivNtool in a nutshell. Here's your clock speeds for your GPU, here's your voltage for your GPU, and here's your memory. And again, I would only mess around with your P3 for the memory. I wouldn't worry about the voltage. So hopefully you guys found this video helpful, and if you did, definitely hit the like button, and let me know what kind of clock speeds you're able to get with your Vega 56, Vega 64. And if you've got a Polaris card, I'd love to hear about your Polaris results as well. Definitely this video went longer than I anticipated, but hopefully it's full of information that you found useful. And I'll be coming back very soon with a few more benchmark videos like I've been doing recently with Shadow of the Tomb Raider and Far Cry 5. And I've also got a pretty big benchmark video coming out just before Radeon 7 that's going to show you what Vega 64 can do at 1080p, 1440, and 4K in a good variety of titles. I think I have about 16 or 18 games tested, so that'll be pretty good. That'll come out before Radeon 7 is released. So if you guys are wondering, should you get that Radeon 7 or stick with your Vega, you'll be able to tell what kind of results you can get in different games at different resolutions and make a decision if Vega is good for you. Okay guys, with that I'm going to end the video. Thanks again for tuning in. We'll see you next time. Bye-bye.